This is part 4 of the chemical changes topic in GCSE AQA chemistry. It's a dual award and triple award topic. Going to recommend you try each activity, pausing as you go. In this video, we're going to take a look at how we can make salts from metals. There are many methods that we use, and in this case, we're going to look at adding a metal to an acid. In the first instance, though, it's another opportunity to look at half equations that came up in an earlier video. And there's a little bit of an explanation here of a step-by-step guide. Going to recommend you pause this to remind yourself and then have a go at trying to complete these. So, in this case, we've got the Ionic equations provided. I've got my Mg reacting with Cu plus 2, going to Mg plus 2 plus Cu. Now, if I break that down, the magnesium half equation is going to go from Mg to Mg plus 2, and I need to balance it. I balance the charge by adding electrons, and my electrons are going to be added to the right-hand side. If I do the same thing with the copper half equation, copper 2 goes to copper, it's reduced. It's reduced because it's gaining electrons. So I've got oxidation, loss of electrons in the top half equation, and reduction, gain electrons in the bottom half equation. And a similar theme as we move through the next one. The zinc being oxidized to Zn plus 2, oxidized because it's lost electrons, and the iron ions being reduced to iron, gaining electrons in the second one. So oxidation and reduction. And finally, on this selection of equations, the lead being oxidized to Pb plus 2, and the copper 2 ions being reduced to copper. Oxidation for the lead and reduction for the copper ions. Now we can take that a step further forward. This relies on you being able to build a half equation or build an ionic equation to then break down into half equations. So let's take a look at these. Well, for number 1, we've got the copper sulfate being broken down. It's aqueous and it's ionic. Salts like this in solution will be aqueous, so can be broken down. At this point, I'm looking for spectators, and I've got my sulfate ions, so I can get rid of them. I rewrite the equation so that I don't include them, and then I break that ionic equation down into the two half equations. Fe goes to Fe plus 2, and 2e minus, and Cu plus 2 plus 2e minus goes to Cu. Second equation, and in this one I'm breaking down the iron sulfate and the zinc sulfate, so Fe plus 2, SO42 minus, Zn plus 2, SO42 minus. My sulfate ions are spectators, let's get rid of them, rewrite the equation without them, and then I can build my two half equations. My Zn is oxidized to Zn plus 2, Zn plus 2 plus 2e minus, and my iron ions gain electrons and are reduced to iron. We can also look at reactions with acids as well. Now, sulfuric acid and hydrochloric acid are aqueous ionic. So think about what that is going to look like. We'll do number 3 first. I can break down my sulfuric acid into 2H plus and SO42 minus. I've got an SO42 minus that I can therefore disregard, they're spectators, and I write my equation out without them. Mg plus 2H plus goes to Mg plus 2 plus H2. I'm now going to break it down into two half equations. My Mg goes to Mg plus 2 and 2e minus. The magnesium has been oxidized. And my hydrogen ions, 2H plus, have gained electrons to become H2. So the hydrogen ions have been reduced. Looking at the next example with zinc and hydrochloric acid, well, I can break my hydrochloric acid down into H plus and Cl minus. I've got Cl minus spectators here, so I can get rid of them, and I can then build my half equations. Zn goes to Zn plus 2 plus 2e minus, and 2H plus 2e minus goes to H2. The top one here is oxidation, the bottom one is reduction. Now, there's a very important practical that you could be expected to explain or describe within your exam. There's also a very important equation, general equation. If you take a metal and react it with an acid, you will make a salt and you will make hydrogen gas. Little bits of information here about the equipment list and about safety, but we're going to take a look at the method. So we take a small amount of the acid, we add half a spatula of magnesium, we stir, and we keep doing that until the fizzing stops, the effervescence stops. At that point, we need to filter the mixture. We'll talk about why in a moment. Once it's filtered and we've got our salt solution, we gently evaporate it in an evaporating basin, allowing the salt to crystallise, and we can make that salt in this way. Some questions about the practical that you're hopefully familiar with. What can we conclude had happened when there was no more fizzing, even as we added more magnesium? Well, if we've got an excess of magnesium and no reaction is taking place, that tells us that all of the acid must have reacted. There's none of it left. So what's then the purpose of filtering the mixture? Well, we've added magnesium until the reaction stops. That means there will be an excess of magnesium, and we don't want that within our salt. So we're filtering it to remove that excess unreacted magnesium. We also need to be very careful in developing skills on naming salts, and little bits that stand out here. The first part of the name is the metal. So whatever metal you're reacting, that forms the basis of the name. And then depending on the acid, the salt will have a different end. Sulfuric makes sulfate, hydrochloric will make a chloride, nitric will make nitrate. You'll also come across potentially phosphoric making phosphate and ethanoic acid making ethanoate salts. So let's have a think. The name of the salt that we've just made, in the method that we went through, had magnesium with hydrochloric acid. So we've made magnesium chloride. Have a go at the rest of the questions here. So the word equation, we've got magnesium and hydrochloric acid making magnesium chloride. We can see where the salt name has come from. And we've got hydrogen gas that's been made as well. We're also going right back to early in chapter 1 here, atomic structure, about being able to work out the formulae of common compounds. Magnesium is +2, chlorine is -1, so the formula of magnesium chloride would be MgCl2. With all of that in place, we're now able to build our equation. Magnesium reacts with hydrochloric acid to make magnesium chloride and hydrogen. All that's left to do is balance it. I need 2 HCl. I've now got 1 Mg, 1 Mg, 2 H's, 2 H's, 2 Cl's, 2 Cl's. So let's do a few more questions now related to naming salts. And what would we make from magnesium and sulfuric acid? That would be magnesium sulfate. Lithium and nitric acid would be lithium nitrate. And iron and hydrochloric acid would be iron chloride. And in every single case here, with a metal being added to an acid, we would also make hydrogen. So that's following those rules that we've just looked at. Now let's think about the word equations. I've started them off here so we know what metal is reacting with what acid. And we've already just established what the salts are. So magnesium sulfate, lithium nitrate, iron chloride. And we've also just established that in every single case, we're making hydrogen. Now we need to do the balanced symbol equations. Now, if I take magnesium and sulfuric acid, I make magnesium sulfate and hydrogen. That equation is already balanced. If I move on to lithium and nitric acid, I'm going to make lithium nitrate and H2. This one isn't balanced because I've got 2 H's here and only 1 H over here. So I need 2HNO3. That then means I need 2 LiNO3, and because I've now got 2 Li, it means I need 2 Li over here. And finally, if I take my Fe and HCl, I make FeCl3 and H2. Straightforward bit of balancing here. I've got 3 H's, 3 Cl's, 3 Cl's. That then gives me 3 H's, so I need 1.5 H2 to balance the H's out. That takes us to the end of this video. Thank you for listening and goodbye.